I received many questions like this. Can you recommend an ideal chunk size for documents for creating embeddings? I want to give an answer by example. So we got 4 texts, 4 short sentences, 4 different topics. And then we've got these texts, 4 large sentences and 4 different topics. So what is the ideal chunk size for each example? 50, 100, 500? In short, none of them. Ideally, you want each chunk to cover a complete sentence or topic to create meaningful embeddings. Otherwise, RAG applications will perform pretty poor. So I'd like to raise awareness about an alternative approach called semantic text chunking. This method involves using a model that identifies coherent parts in documents and creates chunks from them. There exists an approach for this in LangChain, but my experience was not too great with it, and this is why I want to explore with you a package called Semantic-Text-Splitter. In this video, I'm going to show you how to install it and how to use it. Okay, I'm currently in VS Code, and before we start, we will have a look at the bank.txt file. And as you can see, this file includes an example of a bank and some text about this bank, and it also includes a restaurant. So we've got 2 very different topics, so restaurant and bank. And we want to create chunks which are meaningful, and we don't want to use a fixed size because maybe we mix up this and then we've got this about a bank and this about bank and restaurant, and this is pretty bad. So we want to chunk it semantically. So as you can see, we don't directly use it. So I'm first going to show you the normal approach by loading the text into memory with a text loader from LangChain and then using a recursive text splitter. And yeah, this is the standard way. This is done with LangChain, and below we do it with Semantic-Text-Splitter. So first we have to install the package, which is LangChain and also Semantic-Text-Splitter. And first we're gonna load that file into memory and then load it. Now we've got a single variable, which is just this single file, and now we use a text splitter and we use a chunk size of 200 and a chunk overlap of 0. So here it doesn't really matter. I just want to show you how that would look like. So now we've got 20 chunks, and if you have a look at the chunks, each of that contains a little bit of data. And for example, the bank of Ilarion, this is just the name of the bank, but it does not include any other information. Here we've got some other information, and then we got this information about the restaurant. But yeah, this is not too meaningful, and I think this can be done better. So this is why we use Semantic-Text-Splitter. This package does not include a loader like in LangChain, so we have to use the open function, which is built into Python. Just load everything of that file into the content variable and then work with that content variable. So here we can also use a normal character text splitter and split it by chunks. So this is the normal way without any model. So nothing really special about that. So if we have a look at our chunk size, so this is our chunk. We have 21 chunks, so 1 chunk more compared to the solution of LangChain. But now we come to the interesting part. So we can use a Hugging Face text splitter, and this Hugging Face text splitter works in combination with a so-called tokenizer. And this tokenizer makes use of a BERT model. This BERT-based uncased model is a transformer model, which is very good in understanding the context of words in unformatted text. So this is very good for what we've got. So we've got this unformatted text, or more or less unformatted, and now we want to create chunks from that. We can also set an upper limit to tokens, which is 200 in our case. And now we want to create this tokenizer by this class method and then set it as argument in the constructor of the Hugging Face text splitter class. So now we've got our splitter, and now we want to create chunks from that splitter. It takes the content and also the max tokens as argument. And now we've got our chunks. So this is now very different from what we've got before. So we've got chunk 1, chunk 2, and chunk 3. So this looks like it's more about the technical details of the bank, and this is about what the bank does in the community development. And yeah, this is the third topic. It starts with the name of the hairdresser, and yeah, I think that's pretty good and much better than before, where we just split it by the chunk size. So we can also set min token limit and also a max token limit like this. So we can set this chunk capacity. And if we have a look at that again, we can see that now we've got 4 chunks. So it splits a little bit more, but I think, yeah, it's anyway much better than before. So this is just my first impression, and I think it's a very good idea to visualize the embeddings to see the differences. So we import OpenAI embeddings class from LangChain, set an API key, and now we want to create embeddings from that chunks. So first we embed the chunks with no model, and then we embed the chunks with the model. And then we ask, what does your bank do for the local community? And after that, we want to visualize that. So, okay, this is just a little warning because there is no dictionary set for this new embedding model. And now after creating the embeddings, we want to calculate the cosine similarity of the question, which was also embedded against all of the embeddings in this no model list. And again, we do it with the model list. And then we want to print the differences in cosine similarity. So let's do that side by side. And yeah, this is how it looks like. So on the left, we can see that we've got many documents over a 0.4 threshold. And on the left, we can see that we've got 2 documents, which clearly are different from the documents here on the right. And yeah, on the left, the problem might be that we only retrieve too few documents and miss information we may need to answer the question. So maybe I'm gonna show you that again, where we increase the chunk size. Now I used a larger chunk size on the left, and as you can see, the embedding here in the middle is not very well suited for retrieval because it differs quite a lot from the left, but also from the right. So this seems to mix up 2 different topics, like the hair salon and also the bank. So my recommendation is that you give this package a try. I also link it in the description. It's written in Rust for performance, and in general it seems to be a pretty good package. Thanks for watching. See you. Bye bye.